a sphere. Why is it 4/3 pi r cubed? Where does the 4/3 come from? Why r cubed? So let's figure it out. This comes from this, comes from this, comes from this, comes from this. So let's show it. There are other ways to prove it mathematically and all that, but if we start out, we got this. You can show it's base times height, the volume for a prism in general. Then we get this, pyramid 1. Whoops, more water. 2. 3. So 3 of these to fill up one of this, more or less. You know, plastic construction is off a little bit. I didn't maybe get exactly the water in it, whatever, but you see 3 of these for this, so it's a third. And you can show that as you get more and more sides of a polygon, it can become this. That's a separate topic. But, so we can consider this, when you look at the math and circles and stuff, like an infinitely many-sided polygon. So, then we get the same thing with these. It's kind of like a pyramid with infinitely many sides, and like a prism with infinitely many sides. So, our water, 1, 2, 3. So this is a third of this. The volume of a cone is a third the volume of a cylinder. So we shall write that down after I dry off my hands. Now, so we got prism, volume, area of the base times the height of the prism, pyramid. It's like 1/3 of that. So, and then a cone is kind of like this thing. And a cylinder is kind of like this thing. So we can do base times height. It's a cylinder, a circle, so the base is pi r squared. And here we do 1/3 of that. 1/3 area of the base times the height. Okay. Now we get to do some algebra and some cool stuff. So we get our circle. And notice on one thing here, for this to work, these have to be the same height. Otherwise it doesn't make sense. You're not comparing things that are comparable or like. Same base, same height. Likewise, if we get this, the circles are about the same radius. You can see. Done. Done. Okay, and then the height of this has to be the diameter of the cone. I mean the sphere. The sphere and the cone are the same up and down. Diameter of this equals height of this. Same circle. So we got, I'll use this here, a little half of it. You can see it's the same. Okay, so I'm going to use half of this. So I'm going to take the bottom off. All right, so we're going to see what goes with this. We already know that this is 1/3 pi r squared h. We get this. And maybe 2 of these to fill this up or something. Or I mean, like, you know, 2 to fill up a whole sphere. Let's see. We go, well, dang. So about 1 of these to fill up this. So same volume. See again. There. So they're equal. So let's work on some algebra about that. Get rid of this stuff. Now, we got for sphere and cone, where diameter sphere equals height cone, and radius equals radius. Radius of sphere is radius of cone, you know, as we say. A circle is the same radius. So for this only, otherwise they're not comparable and nobody cares. When we got this, then we saw that volume of the cone is half the volume of a sphere, because it was a hemisphere. This is half of this. This is equal to the volume of a hemisphere. So, water out of the way. Then we know that 1/3 pi r squared h equals 1/2 volume sphere. And then we got to mess with this algebraically. So we could undo the half by multiplying both sides by 2. Especially if we get a better marker. 2, there we go. And so that's just the volume of the sphere. 1/3 2 times is 2/3. So we got 2/3 pi r squared h so far, but we don't really talk about a height with a sphere. So we need to change that. The height, remember, was the diameter of the sphere. So h for the cone is diameter of the sphere, and our diameter is 2r. So we can put a 2r in place of that. And so we get 2/3 pi r squared 2r. But 2/3 2 times 2 twice is 4. So that's 4/3. R squared times r is r cubed. Ta-da! 4/3 pi r cubed. Bam! Done. That is so cool. So it's like we get these teeny tiny bits of volume and move them around, layers or little pieces. So it's kind of leading into calculus, where we get little bits of this and change it into be little bits of that. So there we go. That's why we got a 4/3 in it. So 4/3 times, so r cubed is like the volume of a cube. That's r by r by r. 4/3 about 1/3, pi, 3 something. So 1/3 of 3 is 1. And 0.4, 1/3 of 0.4, about 0.04. 4 times that, 0.16. So about 4 1/6 as big as this. If it's r by r using the radius, that's how the sphere would be. In other words, you get the sphere, and you get the radius and make little cubes. Then there'd be like, what do we say? 4, like 4 of these would be the volume of the sphere, if that makes sense. If not, all good. You see what it is. But there's the derivation. 4/3 pi r cubed because of that. Hope you enjoyed. Peace.